Hello there! In this video, we are going to cover Python functions, and we have already seen quite a few. For example, the inbuilt functions that are very commonly used are len, print, and input. Len, for example, gives you the list of items inside of a container. And while these inbuilt functions are useful, sometimes you want to have your own function with custom functionality. And this is what this video will be about. We are going to cover how to create a function that can do basically anything. You always have to start with the define keyword. After that, you will need the name for your function. The naming scheme for this one is going to work basically identical compared to what you have seen for variables. Meaning you should be using generally a snake case and then not start with numbers, not include random symbols, stuff like that. After that, we need parentheses with the parameters. Now, the parameters might be a new word, but basically all they are is a slot for the arguments that we are going to add later when we are calling the function. That's all this is. After that, we will need a double colon, and then we can write whatever code we want inside of the function. Also, we can specify a return value, meaning once you're calling the function, you can either return a value or you cannot return anything. And well, that's basically all you need for the basics of a function. Once again, I am in VS Code and I want to create a new Python file. Let's call this one functions.py. After that, back to full screen, and now we can start writing any kind of function. For that, we generally need two steps. The first one is the one I've just talked about, where we have to create a function. Let's create a really basic one. For that, I will need the keyword define and then a function name. And this function name obviously should reflect on the functionality of the, function. For now, I simply want to create a function that print 5 times. So we want to print a random message 5 times. After that, we will need parentheses, and for now, they can remain empty. Then a double colon, and now if I press enter, VS Code is going to give me one level of indentation by default. And here, I can now write any kind of code I want. For now, let me simply print test. This would be a valid function. It doesn't do anything useful, but at the very least, it's not causing an error. This is the first step, where we have created a function. Next up, without the indentation, we have to call that function. And this is going to work in exactly the same way compared to what we have seen already, for example with print, where we are calling the function with the parentheses. And in there, we can add any kind of argument, for example, print for this one. And the same thing we are going to do for our function, where we want to print something 5 times. And this we also have to call. For now, we cannot add arguments, but if I run the code, you can see we get print and we get test. Print is coming from this line and test is coming from this line. But now, in our case, we want to print this test 5 times. For that, we will either need a while loop or a for loop. I am going to use a while loop, although both answers here would be perfectly fine. I want to once again create a counter, and this counter by default is 0. Then I want to have a while loop, where we are checking if the counter is smaller or equal than 5. Inside of this while loop, I want to print test, and then increase the counter by 1 on every iteration of the loop. And now if I run the code, we are getting test multiple times. I suppose to make all of this a bit more descriptive, let's print the counter. And there we get counter 1 to 5. And if I scroll up just a bit, we can see the 0 as well. And before that, we have print. And that's kind of all you have to know about functions at the very least to get started. Essentially, we are doing something very similar compared to the if, while, or for statements that we have seen in the last video, where we start with a keyword and then we write indented code. The only difference now is that we have a function that we can call anywhere in the code. And this we can actually do multiple times. For example, I could copy this line multiple times, and then we get the same output over and over again. Not terribly useful for this one, but certainly something you can do. Although with functions, we can customize things substantially. Most importantly, when we have the parentheses at the creation of the function, in there we can add parameters. These parameters later on would be the slots where we can add arguments. For example, I want to have the functionality that when I'm calling the function, I can add the word I want to print. Let's call this one test for now. With that, we have an argument for the function. But this, if we are running the code, would cause an error, because print 5 times takes 0 positional arguments, but 1 was given. The function was given 1 argument down there, but it doesn't have a slot to capture this argument. For that, we need the parameter. This we could call whatever we want. For now, let's simply call it parameter. Doesn't really matter what you call it. If I run the code now, we get the outcome as before, but we cannot see the test anymore. That is because we have it available inside of this parameter, but we don't use it. The way this would work is that the parameter is now becoming a variable that is available inside of this function, and only inside of this function. You couldn't use it outside of it. Which means essentially what we can do, instead of the counter, I want to print the parameter. And now if I run this again, we get test printed multiple times. And just to see a bit better what's going on, let me print the counter and the parameter. That way we get 0, test, up to 5 test. We have added the string test to the function, which was captured by the parameter, which then became a variable only available inside of this function. The way we have used that is inside of the print statement, where we are simply printing it. What you could also do is add a second parameter. In fact, you can have as many parameters as you want. For example, what you could specify is, let's call it the loop amount, which is going to be the amount of times this while loop will run. To use that, we simply want to check if the counter is smaller than the loop amount. After we have that, we also have to give a second argument for this print 5 times function, although the name now doesn't really work anymore. But that's an issue for later. Let's say I want to print this test only 2 times. If I now run the code, we get test 3 times, because this one should actually be a smaller than instead of a smaller than or equal to. If I now print it, we get test 2 times. If I instead change this to a 10, then we are printing it from 0 all the way to 9, or 10 times in total. Also, while we are here, let's rename this print 5 times to print x times, both when we are creating the function and when we are calling it. That way the naming makes a bit more sense. Another super useful thing that you can do is to create a default parameter. Let's say by default you want the loop amount to be 5. Meaning if the user doesn't specify a custom number, let me remove it, we want this loop to run 5 times. For that, you can simply add an equal to 5 or whatever default value you want inside of the parameter when you create it. That way, if I now run it without the second argument, we are getting the loop 5 times. You could also specify a default parameter. Let's call this one loop. That way, I can call the function without any arguments whatsoever, and we get the loop 5 times. However, if you do specify arguments, let's say some new numbers, I want to print something, and I want to print that 4 times. These values, if I specify them, are going to override the default values. That way, you don't lose any functionality by creating a default value. Instead, you basically create a backup variable. So if the user doesn't specify the value, you still have at the very least something. There are 2 more really important things that we have to cover before we finish the basics of function. Number 1 is you can specify a return value. For example, for this function, after it finished running, I want to return some kind of value. For example, we could print out the loop amount so we know how many times the while loop has run. For that, you need the return keyword. Anything you write after that will be returned by the function. In our case, we want to return the loop amount. And that way, if you are assign a value to a function after calling this function, let's call this one test, and the value of this will be whatever we get from this function. And then on the next line, I want to print test. If I now run this, we are getting the value 4. This is what that function returned, or more specifically, what we have gotten from the return statement. If I change this to, let's say, the string something else. Then the function is always going to return this exact string, meaning if I run it now, we get something else. With that system, it becomes quite easy to get a function that returns some kind of value after you call it, which makes it quite easy to connect it to some other parts of your code. And this sometimes might become really necessary, because there's one thing for a function that can be very confusing and quite frustrating. When we have a function like this, you can create variables inside of it, like the counter I have created on the first line of the function. However, what is really important to understand is that this variable is only available inside of the function. This is called the local scope of a function, which means whatever variable you create inside of this scope is only available inside of the scope. We wouldn't have access to it outside of it, which incidentally is called the global scope, meaning this is the local scope inside of a function, and then we have the global scope, which is the general unindented line of any Python document. Also, if you have multiple functions, you have a local scope for every function. Sounds a bit complicated, but basically what it means. Imagine I want to print this counter somewhere else outside of the function in the code. For example, I want to print the counter after we are calling the function. If I now run the code, we get name counter not defined, because this counter only exists within this function. It doesn't exist outside of it, so Python gets an error. What is, however, possible is to have a function that looks at the global variable, so a variable I created outside of the function. Let's call this one global var, and for the value we can go with global variable. This global variable is available inside of the local scope of the function. For example, we could simply print global var. If I now run this, we get, if I go up a tiny bit, the global variable. And this should make sense. Global variables should be available everywhere. They should also be spelled correctly. That usually tends to be good practice. These variables are always available to any function, so even in the local scope of a function. However, a local variable, like the counter, should only be available in the local scope where it is needed. The reason for that system is that we have more modular code. Imagine you have 10 functions and all of them do some kind of counter thing. If you had the variable name available for all functions everywhere, then you couldn't reuse this counter. You would always have to find a different kind of variable name, which might be doable with 14 lines of code, but imagine you have a program with 10,000 lines of code. You don't want to look through the code editor for every variable name. Especially if you work with multiple people, this would be a nightmare. So global and local scope are really important to understand. But other than that, this is basically all there is to functions. They don't get that much more complicated. I suppose we could do one more example. If I exit the full screen, very early on, we have written a Pythagoras theorem calculator that looked like this. If you are watching this on YouTube, check a few videos back. This is where we created this. Ultimately, all we are doing is this formula, where we are getting the power of one side, the power of the other side, and we are putting all of this inside of a square root. That way, we're getting the hypotenuse of a triangle. Within this Python document, we are doing all of this over 4 lines, which really isn't ideal. So instead, let me copy all of this and instead create a, let's call it a hypotenuse calculator. And inside of there, we are going to paste in all of the code. Now, we have to make a couple of updates for all of this to work. Also, let me go back to full screen. Now we can work with this. Oh, and a really nice feature inside of VS Code is if you hover next to the function, you can minimize it by clicking on the arrow. Makes our code a lot more organized. Ultimately, all I want is I simply want to call the hypotenuse calculator, then supply 2 sides, and then the function is going to return the resulting value. Ideally also rounded. All of this at the end, I simply want to print. So let me print the hypotenuse and add some basic values. Let's say 5 and 10. We will need 2 parameters, one for side A and another one for side B. With that, we also don't need the input statement anymore. I actually want to get rid of both of these lines of code because they're not needed anymore. The only thing that we really need is the hypotenuse, and in there we still have the correct formula. This one can stay as it is. I suppose what we can do while being here is standardize all of this. We should either use the power with 2 asterisks or the power function. Both would be fine, but we should only use one at a time. Let's say I want to use the double asterisk, so side, asterisk, asterisk, and 2. Also, this should be side B. That way, all of this looks a bit more consistent. After we have that, we get the hypotenuse, and this is what we want to return. So return hypotenuse, and then I can comment out all the stuff we have done before, so we can focus on one thing. If I now run all of this, we get some kind of value. To double check this one, let me change the numbers to 1 and 1. That way, we know the value should be 1.41 and then a whole bunch of other values. So this seems correct. Although I also want to round it because these are way too many numbers. And rounding we can do right away when we are returning the value. All you have to do is wrap it inside of the round function and then specify how many numbers you want after the decimal point. In my case, 2. If I now run this again, we get 1.41. With that, I can use other values, let's say 5 and 4, do the same thing, and we get 6.4. That feels much cleaner. Also, what we could be doing for the hypotenuse calculator is define default values. I think 1 and 1 would be pretty good default values. Finally, before we finish, there's one more thing that I do want to cover. Sometimes you have a function with a huge amount of parameters, which can be quite confusing. In that case, it might make sense to specify which argument corresponds to which parameter, which is called named arguments. Basically, all you do is you specify the parameter when you're calling the function and then assign it a value. In this case, I want to have side A and side B and then assign them a value. With that, I can run this again and we still get the same outcome. That looks pretty good. Now for this function, this wouldn't be particularly useful, especially since we can exchange the numbers and would still get the same outcome. But imagine we have 20 parameters, then the system makes a whole bunch more sense. It can also be a good system if you just want to be really specific about your arguments. So use this whenever you feel it's appropriate. If you practice a bit, it becomes fairly intuitive. Alright, with that, we can do an exercise and then we are good to go. I want you guys to create a shouter function that takes 2 arguments, a string and a number. The logic you should be writing is that the function prints the string multiple times, whatever is specified by the number. Also, while you are doing this, capitalize every letter that is printed. On top of that, if the number is greater than 10, don't print the string, instead print something like you are too loud, but only print this once. Finally, the function should also return the string done once it is done, and you should have default values. Quite a bit to work on. Pause the video now and see how far you get. Back in the code, I want to define another function. I suppose shout would be a good name. We will need 2 parameters. One would be the, let's call it the output string, and then we have the repetition amount. I think those are names that are a bit more descriptive than simply parameter or loop amount. Also, let me minimize the other functions so we don't get confused. We want to print the output string as often as the repetition amount. Also, we want to capitalize the output string. Capitalizing the output string is the easier part. All we need is the upper method, and don't forget to call it. Also, while we're here, let's call the method right away under an exercise bit where we are calling shout. And I want to shout test, for now, let's say 3 times. If I run the code, we're getting test capitalized. That's a good start, although we only get it once. To do it multiple times, we need either a while loop or a for loop. The while loop we have already used up here, so that's a good start. But it's not the most efficient way of doing it. Instead, you would most often use a for loop. Let's say for I, And then we want to loop over an integer, in this case 3. Unfortunately, we couldn't simply add the repetition amount in there. We would get an error. If I run the code, we get int object is not iterable. The way around that is another function that we have to wrap around the repetition amount, or the number we want to use. That function is called range. If I now run this, we're getting test 3 times. What range does is it creates a list of values. As a matter of fact, let me show this actually. I want to print range and then the repetition amount. If I now run this, we're getting a range object, which isn't terribly useful. To actually see what's going on, let me wrap all of this inside of a list function. And now we are simply getting a list with the values 0, 1, and 2. And if you increase the number to, let's say, a 5, then we get the values from 0 to 4. Range can be super useful if you want to loop over an integer. It can also be a floating point value. And the range function can also specify a start point and a step size. It's somewhat similar compared to slicing. But in our case, we don't really need that. We simply want to use the basic functionality of it, which is all we need for this part. That covers quite a bit of the exercise. Next up, we need a functionality that we don't want to print anything if the repetition amount is greater than 10. For that, we will need an if statement. I want to check if the repetition amount is smaller, or let's say equal compared to 10. Only if that is the case do I want to run this for loop. Meaning all of this needs to be indented one more time so Python knows the for loop is part of the if statement. Now, if I run the code, we are still getting the test 5 times because 5 is smaller than 10. If, however, I change the 5 to a 12, we are not printing anything, simply because the if statement didn't trigger. However, what we can do, on the same level of indentation as the if statement, we can add an else statement, where we want to print, I think I said, you are too loud. Could also be anything else, it doesn't matter. If I now run this, we are printing you are too loud. Next up, we also want to specify a return value. And this one, by the way, always has to be at the end. Whenever a function comes to a return statement, it is not going to run anything afterwards. You are effectively ending the function. Although in practice, you usually only want to return a value once the function is done, so it's not that big of a deal. In this case, we simply want to return the value done, or rather the string done. That way, if I create a new variable, let's call it the status, and the value for that is going to be whatever we get returned from the shout function. And this status I want to print. Let's now run it, and we get you are too loud and done. Nearly done. The last thing that we have to add are default values. Let's say for the output string, I want to have a default value of hello, and for the repetition amount, I want to have a default value of 2. With that, I don't need any arguments, and I can simply run the code, and we get hello twice, along with done after we are done. And with that, we have functions.